Welcome to the Build It Better podcast, powered by FrameCAD. I'm your host, Robert Johnson, and today, this is awesome. Coming to us from Australia, and is it Melbourne?
Melbourne, yeah.
Okay. Australia is Peter Blythe with Dynamic Steel Frame. Am I saying everything correctly? Don't let me say your name wrong for the entire time.
No, you've got it bang on.
Welcome. Tell us a little about your company, and then we'll dive into some discussion.
Okay, so we started Dynamic Steel Frame in late 2011, early 2012, and it came via a very fortuitous purchase of a second-hand machine, a FrameCAD F300, I think machine number 18, so quite a while ago. And started with just myself and my business partner to the side, of course, but myself in a factory with a machine on my own, rolling steel frames. We were rolling stick-built stuff, so we were just rolling kit for a shed company, and we were sending product as far north as Townsville and Toowoomba, which, if you don't know Australia, Melbourne's at the very, very bottom, and Townsville and Toowoomba are at the very, very top, so about a 3,500 kilometre journey. And we were shipping our product all the way up the East Coast. It was a very simple model at that stage, and then slowly but surely we obviously progressed, and I don't mind selling, so we got out there and started selling, and started in the commercial commercial sector with a job in a place called Box Hill, and that was really the start of the business as a commercial framing entity. And we manufactured a 1,100 square metre top story in Box Hill, and that was really the catalyst for the entire industry in Victoria to start doing what we call top level or podium framing on these apartment buildings.
Interesting. So you started out, again, doing shed stuff, just whatever you could, basically, to get keep the machine running.
Every meter's a good meter.
Yeah, and then went into commercial.
Yes.
So are you doing much residential stuff, or are you still mostly commercial?
Yeah, so we don't do a lot of single houses. When we do a single house, what we would call residential, they're generally really big. They're luxury. Okay. They're massive. They're projects that people love, and they really like to get involved in them. And that's the sort of project I like. We don't get much into the, send us 100 house frames and we send you 100 frames, out the door, with no real contact. We like to get involved in the process. So that's why when we do houses, they're big, and they're luxurious, or they're owner builders, and the owner builders want to get into the design process. Mm-hmm. But what we do is what we sort of consider commercial residential, which is townhouses, right? So we like big townhouse projects. Our biggest one so far is 135, which we're working through at the moment. Okay. And prior to that, it was 116 and 106 and 75. And the reason we like those is because our design team can get really into the design. So rather than just getting a set of plans in, drawing what's on the drawings and throwing the frame out to site, we, and I think we're probably the best at it, we will design or redesign and optimize the structural steel. We will check that the plumbing works. We'll check that the falls in roofs work. We check that the falls in box gutters work. We produce a digital twin of the building that is far more detailed than I think the market has ever expected to get from a framer, right? Mm-hmm. You certainly don't get that level of detail in timber, or you haven't in the past. When I first started the business, the frame designs I saw coming out of the timber industry were very, very rudimentary. I mean, the software is great, but the communication to the customer and to the framer was two-dimensional drawings. Mm-hmm. We started, we were the first people to put frames up on Sketchfab. We were the first people to start what we consider BIM modeling, I guess you'd call it, of the frame, and putting in plumbing and putting in all the bits and pieces to a building, which we're not paid for. It's not really our responsibility commercially, but there's this little thing in the contract that says the frame must be ready for all following trades. So, if a plumber says, hey, there's a web in the way, and the builder calls us and says, hey, who's paying for this web to be moved? So, from my perspective, I don't really like paying back charges and having to do rework on site. So we put all that extra time in for that sector. So we do residential, and residential is the vast majority of what we do, but it's just not single houses. It's
not
2, 3
single family homes.
houses. Yeah,
makes sense.
Yeah.
So, I guess Australia is my hero when it comes to cold form steel. We are today, I feel like, where Australia was 7, 8, 9, 10 years ago. That's where we're at today in the U.S. And it's just getting people to adopt and getting people to understand it, and for all the reasons that we know that it's good, it's just a real struggle. What did you see, or what have you seen as the major movers for people to go from, that have adopted and that are doing it more so than they used to?
Okay, so builder-wise, so I'll start from my commercial side. Mm-hmm. So the commercial side of construction is all about time. Time is money. Mm-hmm. You've got overheads, you've got site managers on site, you've got people running a project, and when you're building a 3,000 or 4,000 square metre building, there's a lot of moving parts. You've got crane time to worry about, you've got lifts from street to worry about, street closures, all this kind of stuff. So from a commercial perspective, when time is money, the builder and the project managers looked at what we were providing, which was replacing either a concrete top level, which is really expensive, or a structural steel and non-load bearing, plaster stud arrangement, which requires 2 or 3 different trades. You've got your steel fixers, then you've got your roofing guys putting in all your purlins, then you've got your internal guys, and you can't actually waterproof the building until that roof is on. Right. So what the commercial builders found, and I tip my hat to Julian York, who was my first ever commercial customer, and we worked together for a number of years, we still do. He saw it as a way to domesticate, I guess you call it, or use domestic style construction, load bearing walls and roof trusses to replace 2 or 3 different people on the top. So that particular project, again, load bearing walls, load bearing trusses, very domestic style construction on a commercial construction site. So it speeds up construction considerably. And that process of that commercial side of things is what got us going. So the commercial guys started to understand that we were going to that nth degree of plaster tolerances, where the plaster has to start and stop for your fire ratings to run through, making sure that, using the design software, that the plumbing stacks or the voids or the areas to put services was the right size. And we were making allowances for the plasterboard, and we were making allowances for whatever has to run through that area. And that then became this design-led approach that everyone's talking about now. We've been sort of doing that design-led approach for the last 10 years. Right. And seeing everything in 3D and being able to articulate what the building's going to look like really got grabbed by that the commercial construction sector, because no one else was doing it. The structural steel guys doing your posts and beams and purlins, they weren't doing a model. They were looking at a structural plan, and they're plus or minus 20, 30, 40 mil, because that's just how it's always been. And then everyone comes along, and then they build around what's there. And the amount of time taken to tweak this and move that was just huge. So we provided enormous amounts of time and labour savings on site, because we were creating a digital twin first. So from that, I believe then the commercial builders started building their own houses with us. Right. And then we do a house here or there, and then we do some facades and some balustrades, and we pioneered curving light gauge steel. And there's some amazing projects we've done where we've actually invented a way of curving light gauge steel and making prefabricated balustrades that are pre-clad and just lifted onto a building, and doing some wild things like that. People just look at it and go, wow, what can I do? So then facades on buildings and facades on houses start to get attached. And then from that, then the commercial builders who are watching what we do on the socials, because we share a lot, as you know, we're probably one of the highest sharing framing businesses, I think, in the world. I don't know if there's anybody else who's got as much content as we do. And using that, generating the interest from there, then the townhouse guys came along and said, hey, we saw what you did there. We would like to, do that design-led approach on our builds. And even though it was the price sometimes against just stick-built wood, stick-built rotting vegetables, I like to call it. It was a bitter pill to swallow at the start, because in one of our first really big townhouse projects, the developer was a commercial builder, right? And he was hell-bent on steel, and he forced his builder to use steel. And they went, man, this is too expensive, and we're really doing this under duress. And since then, that builder, we've done 300 or 400 houses with them, because they got the process. We drew it, we made sure everything worked first, and then when they get to site, they're using half the supervision they need. They started one of the sites with 3 site supervisors, and they ended up with 1, because no one was having any arguments with trades, no one was having to figure anything out. So it was a really smooth process, and I think that's why we've got into that part of the market.
And you bring up a fantastic point, is that there is so much more work that goes into this in the beginning and pre-construct what people typically see as pre-construction than is in a traditionally constructed project.
For sure.
So much done so early, all of the coordination, the back and forth, the doing the modeling, the clash detection, all of those things really does make the project. It's not just building an efficiency for us because we're the ones that are turning the frames and building the building, but you're building efficiencies for every trade that comes after you. And when builders get that, it's like an aha moment for them. So very, very interesting.
The project really. So we often, around our boardroom table here, we'll often have the plumber, the sparky, the HVAC guys, the architect, the engineer, the builder, the carpenter who's going to install it, the facade contractor who's going to clad it, and we'll all sit around, like we'll huddle, right? And we'll go through all the issues of the building. But then when it's all in 3D, we've got this big screen that I'm talking to you on now, and you can see it, and you can understand whose trade affects the other trade. But once it's there, it's ready to go. The HVAC guys have prefabricated to suit the holes, not coming out on site, figuring out what space they've got to work inside of. It's already done. So often we'll have a fan core unit delivered to us so that we can make sure that we model that fan core unit. Now, I got a bit of pushback on one project from the mechanical services guy. Why do you want one of these things? I think he thought we were going to steal it. But what we found when we modeled it is that the drawings given to us just showed a block, right? And had we just modeled in the block, it would have been wrong, because all the air conditioning pipes came in the side, and had we not modeled those ourselves, it would have hit all the trusses. So, it's the next level kind of stuff that people don't sort of appreciate sometimes when they're coming to us as a business or as steel framers in general. They don't get A, the level of detail that we can provide, but B, the level of detail we need to make it sing. So rather than trying to chop and change stuff on site, which is slow and costly, no one ever wants to pay it. Some of the frustrations our builders get sometimes, and I know you guys get frustrated with how much information we ask for sometimes, there's a really good reason. Because we want, when it gets to site, what I like to say now is no decisions on site, right? No one should be having to make decisions about how to do something on site, because all those decisions should have already been made.
Absolutely.
As a digital twin first, and then when it gets to site, it's just follow the recipe. Just put it up and it'll work.
Yeah. And when we tell people that, they don't get it until they experience it.
Yeah.
And I tell this to people all the time. I have yet to have a customer, when I was in the manufacturing and the installation side of the world, I have yet to have a customer come back to me and say, this wasn't worth it, I'll never do this again. 100% of them have said, wow, now we can take what we've learned and we can build on these efficiencies, and it makes them rethink their next project and the one after that. And it really kind of changes that whole mindset from both the developer to the general contractor to all the subcontractors on the job.
Yeah. So we often, well, not often, all the time, we have the PMs and the project managers and the contract administrators and the site guys. They come out and they've learned to really love the process. It's much warmer in an office when it's winter, and it's cooler when it's summer.
Right.
Make the decisions here and have the fun here. And it is fun. It is a fun process to actually get it right first. And then once they've had that experience on one, like you said, they know what's coming, they know when to come and see us, they know how early to get the designs to us so that they can make it sing and make the plan. And a project manager likes to plan. They like to see their plan come to fruition in an ordered, logical, profitable way. And as they say, it's the 6 P's, right? Piss poor planning it's prior planning prevents piss poor performance. So they like to fix the 6 P's in an office rather than on site.
It's so true. It's so true. To me, that's the exciting part about this whole thing is, now that I'm on the equipment side of it, I get to go out and talk to a lot more manufacturers and fabricators and installers that I didn't get a chance to do beforehand. And the people, everybody is experiencing the same thing. It's light gauge steel. It's going to cost more than timber. The cost is going to be too prohibitive. It's all the time. And when you start explaining the benefits of the system, they get it. Now, a general contractor is not going to reap most of the benefits, but that owner or builder or developer is going to get all of that from insurance savings and all those things. So it's an interesting fight. What has Australia done right that the U.S. has not figured out yet?
So I think, from my understanding of the US, it's always been quite a fragmented. One guy makes the steel, one guy galvanizes the steel, one guy slits the steel, then it goes to a manufacturer, and that goes to a wholesaler, it goes to a distributor, and then the general contractor is the guy screwing frames together on site and then standing it up. So that's still a very that's a lumber-based approach, right? You're getting bits and pieces, and correct me if I'm wrong, but you're getting bits and pieces. You might have some cut to length stuff, and then it's going up on site and getting installed, right?
Yeah.
We're a big country, and we're only populated around the outside.
No, so I find that very interesting. Yeah.
Yeah, we don't have that manufacturing base everywhere, and we have this tyranny of distance to overcome. So rather than send stuff to sites, and sometimes some of our sites have been in 5-hour drive away, and we're still in the same state. We're sending a finished prefabricated thing a long way away to where there's not many people. And that's sort of the remote stuff works really well that way. But I think also we've always been, well, not always, but for a long time we've been a truss and frame country. The frame got built, the trusses came in prefabricated, and look, for a long time that was wood, right? But we just like to prefabricate stuff off site, stand it up, and I think that's been not the catalyst, but I think, I don't know, what have we done differently, or what have we done right? We have a really good backing from one of our only big steel manufacturer in Australia, TrueCore, or BlueScope Steel, right? So BlueScope Steel have been driving a product called TrueCore, right, which is their steel brand, as a product to buy, right? It's like a brand, where I'm not too sure there's a brand in America pushing it that hard, because you've got so many people making it. So we're a bit different. We've got one company, and they've got their ColourBond, and ColourBond is a brand known worldwide. It's it's almost like rollerblades or hoovering. It's just the word you use for roofing, whether it's ColourBond or not. And so that TrueCore is their other brand, and they've been pushing the brand, advertising on TV, advertising on radio, doing TV shows like The Block that we do quite a bit. So that's been a good push as well. And also a lot of the roll formers, the automated roll formers started their life in Australia back 25, 30 years ago. One of the first automated roll formers making frame and truss, wall frames and wall roof trusses and things was in Australia. And then a lot of the manufacturers, even FrameCAD is manufactured in New Zealand, which is our next door neighbour across the ditch. So it's been an area where there's been a lot of development done as well. And I think that's probably one of the reasons why we're probably more advanced. Also, Australians are probably a lot smarter than Americans.
Yeah.
So maybe that's the case.
When it comes to this, there's no doubt. It was funny, because of, and you brought it up, your presence on social media, and there's a few others in Australia that do a good job. And for the longest time, I was like, man, there must be 90% of the homes in Australia and structures built, with prefabricated panels, and and I get out there and I find out that 10 to 15% of the market is steel, and when I see that amount of work there, and I think, boy, if we could just get 10% of the market in the U.S., we would all become millionaires. It's an interesting piece. I think, and I asked the question the way I did on purpose. I think we're just behind, and this goes to your comment. The U.S. prides itself on being the first and always being we are so far behind on this prefabricated cold form steel thing. The East Coast, it's more prevalent than the West Coast. Out here, people don't even know what we're talking about. There's still large cities. The 7th largest city in the United States here in Phoenix, and the first load-bearing mid-rise structure was done a couple of years ago. It's like, you got to be kidding me. So it's just we're behind the curve. We're slow. I won't. I do kind of like the throwdown though. It does make you look smarter. And besides all that, well, look, you sound smarter.
I think we like to give it a go, right? And I think Richard Branson said, if you don't know how to do something, say that you do, and then go to figure it out.
Exactly.
And my favourite is every young Australian boy's motorsport, hero was Peter Brock, and he once said, "Bite off more than you can chew, and then chew like hell." And I've used that as the basis of how we do things here, to grow as hard as we can, or as hard as we have, and as fast as we have, because why not give it a crack? And we've given it a crack, and it's sort of worked. You talk about load-bearing buildings. Our first multi-story, or level above level light gauge apartment building was a 4-story building, completely out of light gauge steel. There was very, very few structural members, and back then that was unheard of, and that was about 9 years ago. And we've built 2 or 3 since. But we haven't done a lot of that in Australia, because a lot of the commercial builders still like to just go concrete, steel on top, stick built in between, because that's just what people do, right?
Yeah.
But we're looking forward to doing a lot more mid-rise stuff in light gauge, because you look at the UK, you look at the US, there are people doing lots of lightweight, and that's timber lightweight and steel lightweight, but they're doing lightweight construction up to 8 or 9 stories. And there's no reason we can't do it in Australia. It's just got to get past all the authorities and all of the tick boxes, and we're very, very highly regulated in Australia, like really highly regulated. So, that takes a fair bit of effort to overcome.
Sure.
But we've pioneered a lot of those issues, overcoming fire issues, acoustic issues, all that kind of stuff. We've done it. We've built full-scale buildings or full-scale rooms inside our factories, and when it's quiet at night, we do acoustic tests and we do the knock test, and we've imported machinery or testing devices from interstate and done testing stuff, and we've done destructive testing of our floor joists, destructive testing of wall frames. We've done all that kind of stuff because I'm a mechanical engineer. I like the technical side of things, and being able to do that is fun, and I like to make the business fun. So using that fun approach, we've been able to build some really highly technical stuff. So it's been fun.
It is. It's quite fun. So you mentioned something about lightweight, and it made me think. I just saw, maybe within the last couple of days, a post that you guys did where you're doing something with lightweight masonry.
Yeah, which is very cool. So bricklaying 7 stories up on a commercial building is very complicated in Australia. You've got staffing issues I won't go into too much. You've got working at heights. You've got additional cost for working. The higher up you go, the more you have to be paid. Transporting bricks, which are heavy, 6-7 stories up. You've got all these issues of speed, of quality, of stuff dropping off the wall, bricks dropping through during construction. You've got all these issues. Now, what we've managed to achieve with Melbourne Masonry and our friends at Co-Build, who believe in this. We have a lot of builders who believe that we can do something. They come to us and they say, "Hey Pete, hey Dynamic, can you do this?" And we go, "Of course we can." And then we go and figure out how to do it later, right? But this particular one, you get a normal brick and you cut it into thirds, and then there's like a channel machined into it. So the bricks are basically machined, and then they clip into a rail. And we didn't invent that. Like, it's not us. We're not inventing that, but we're using it. So it's a brick and rail system. And this particular project, you've got verticals, so you've got your columns and you've got your spandrels, you've got your mullions, I should say. So we're basically creating a frame which they're cladding with brickwork horizontally, and then on site they're lifting them up and they're craning them into position. So in order to do that, we've had to work out the weights and things of rotating, because the most work the panel is ever going to do is when it turns to vertical. Other than that, it's just a gravity load. Bracketry, connections, modelling of buildings, getting surveying done so we know where stuff is, getting 3D point cloud scans of the building so that we can actually model with basically a picture of, an as-built as we go, and develop a system around that, right? And that's been frustrating on the first job, really frustrating, because we're having to invent stuff. Every time we do one of these, what we like to call our hero projects, we never make money out of our hero projects until we get to do them the second time.
Yeah, exactly.
The first time you spend hundreds of hours inventing stuff and no one gets paid for the inventing. So once we know how to do it, then we know on the second one how to do it and to actually be profitable with it. Now, we've done a few projects like that. We've done the world's largest, and I'm happy to be corrected on this, but I'm pretty sure it is, the world's largest light gauge facade ever created, where with Industry Cladding and Roofing and Castle Rock Property Group, we invented a series of facades that were 14.5 meters tall. I don't know what that is in American numbers, 45 feet maybe? 45, so 14.5 meters tall, 8.5 meters wide, and over 2.5 meters deep. And they were constructed in 4 pieces, so top, bottom, and the legs. They were transported 90 kilometers away. They were pulled together on what we call the dance floor, clad in standing seam, and the cladding was just extraordinary. And then picked up like a tilt slab concrete panel, a precast concrete panel, rotated in midair, and then offered up to the building. And that was done on a government building where there was 18 of these modules, and either side was identical. And then as it went down, because it sort of came out and beaked out, and that saved between $750,000 and $1 million Aussie dollars on time, scaffolding, on all kinds of stuff. And that had to be invented, right? So the brick stuff, and hopefully I'll do another one of those facades again, because it was amazing and it worked, but it's very rare you get to be involved in a project like that. But the brick facades are a similar concept. We have to invent the bracketry. We have to invent a way to do it that's safe, that's effective, that accounts for slab deflection, and a lot of the stuff most people aren't thinking about. You have to understand that a slab does this, and when it gets hot and cold, it moves. So you have to make stuff to accommodate all of that. And one of the funny things, one of the funny comments, architects are always very particular about how they want a building to look, of course. And when they said at the start they were pretty hesitant about going to a prefabricated brick solution because they weren't too sure it was going to look any good. And then when they saw a sample down at our Masonry friends, they said, that looks too unreal, like it looks so precise that it looks fake. Can you make it a little bit less cool, like a little bit less accurate? So we've gone from sort of thinking that a project is going to look crap because it's prefab, and there's still that perception that sometimes prefab is lower quality. It's not, it's always higher quality. The perception that it's going to look bad to it looking too good and looking too much like a render, and hey, can you make it look a little bit worse? Can you make it look like it was bricked up 60 years ago, by a drunken sailor, for instance? And that's what Melbourne Masonry have done. They've made it look just the right amount of not quite right to make it look like it was done on site, because doing it off site, it was too good. So that's
hilarious. For those that are listening or watching, do yourself a favor and look up Dynamic Steel Frame on Instagram. And you are on Instagram, correct?
We're on LinkedIn, Instagram, YouTube, Facebook. Yep.
Correct. Yeah.
If you want to hear about that big facade project, look up Morwell, Morwell, and I'm sure I've always wanted to do this. Put a link in the something to click through to that video, because it really was an amazing lift and build. It was great.
Yeah, I'm gonna look it up myself. So what is this? I just, it's so funny. You go through Instagram, you're doing your thing, and I see you in some kind of high performance car.
Yes.
What kind of car? What is it that you're
business in order to pay for race cars? I've got an R33 GTR, which I've rebuilt from my business partner's car. It's an ex-Targa Tasmania car, and makes about 700 horsepower. By the time we've got the new engine in, it'll be about 850 to 900 horsepower, hopefully. And that's a lot of fun to drive.
Yeah. Any close calls? Any close calls?
Never, no. But it has an extensive roll cage for when I do have a trip into the scenery one day.
Yeah, it's kind of part of it, but you've built for it. So what have I not asked you that you would want to make sure gets out?
Not sure. It's a good question.
Anything in particular that any news that nobody else knows about?
So we have recently implemented a new machine which we call Hyperspan, right? So traditionally we've been making a lot of web trusses, so W trusses at floor joists, and we've had two 75mm frame CAD machines with about 10 people hanging off the end of them, just putting screws in holes all day, all day. Pretty repetitive work, hard work, not a lot of fun. But then more recently, we decided we'd move to a deep sea machine, and that deep sea machine is able to put out around twice the volume of finished floor joist that my two 75mm machines could do, and with one person operating the machine. So it's like a 10 times multiplier, even more if you look at it from a labour versus output, it's almost a 20 times multiplier. So that's a really great system. We can model that very easily. We can put the penetrations precisely where they want to go, but also on site, all the bracketry. So instead of attaching a joist to a wall and then putting a triple grip here and a triple grip there, it actually has tabs that fold out of the receiver channel, so the perimeter beam, and that makes site really easy, because we like to precisely position our joists for bathroom set downs and load bearing points and all that kind of stuff. But often on site, or not often on site, earlier on, people would just lay out joists at 450 centres, not really look at the drawings, even though we position stuff precisely. So the perimeter beam with the tabs that fold out is precise. So we get the trades don't need to measure, so long as they get those perimeter beams in the right spot on the party walls or on the end walls or the load bearing walls. They just bend the tabs out, which have been punched by the machine, precisely where they want to go, which is unreal. And then we've actually created it as a boxable profile. So we can do 200, 250, 300 and 350, but we can box it. So if we start looking at a boxed 200 mil by say 1.6, that's as strong as a 240 LVL 60 or something like that. And we're still working out our span tables on that. But if you think about a 300 deep boxed member in a 1.9 or a 2.4 millimeter thick steel, we're starting to knock off 250 PFCs, 300 PFCs, and all with a size that you can just lift up by hand. So instead of having a 300 floor beam or 300 PFC floor beam or a 250 PFC floor beam sitting on posts, we can put in a hyperspan beam sitting on a stud pack, so a couple of box studs side by side and whatever else. That drastically reduces the amount of structural steel required. Cantilevering balconies coming out through party walls to pick up balconies, really easy. There's no structural I say no structural. We try to get away with as little structural steel as possible, because that's sort of our MO, our modus operandi has been eliminate structural steel. We do fabrication. We fabricate about 30 or 40 tonne of structural steel a month, but it's after the building's been optimized as hard as possible. So you're never going to get rid of portal frames on the ground floor of a 3-story building, for instance. You have to have it, but we've been really leaning on these hyperspan beams in floor systems, and it's been really, really good. We sort of intimated earlier there's been some issues with why steel has exploded in the last few years. Obviously, there's been a timber shortage. The whole world has experienced this timber shortage, and everyone likes to talk about sustainability, but if you can't get it and there's not enough growing, it ain't really sustainable, guys. We can make a beam that in various sizes and gauges that is going to just eat up the LVL market. And we have an almost infinite supply of it, and it's infinitely recyclable. So, in 100 years, you can take that beam out, you can melt it down, you can make a new one. You can't do that with anything else. And that hyperspan technology it's the next thing. So I think we'll see less and less web trusses getting manufactured. When we first started, we had one machine that did wall frames, roof trusses, floor joist. Everything we need came off our first machine. Her name's Katrina. She's been going a long time, still punching it out now. I think we're close to done over 4 million meters on that machine in the last sort of 10 years, 11 years. And then I've got 8 or 9 others. But early on, one machine does everything. And as we've grown, we've specialized the machines. And I think more and more floor systems, 300 deep with the holes punched in them, is just what's going to be the sweet spot. And having that new machine has been really, really good. It's reduced our reliance on just labour a lot. And we all know how hard it is to get labour these days. So that's been a good one.
That's awesome, and I'm hearing more and more things like that. Not quite as articulated as well as you just did, but yeah, that's some really good stuff. Well, we're going to have you back on again, and I am bound and determined to do it in person somehow, some way. I apologize. We were going to do this hopefully in an airport or somewhere when I was there, and we didn't make it happen. But thank you very much, Peter Blythe, Dynamic Steel Frame. Look him up on Instagram, Facebook, LinkedIn, you name it. They're there, and you can always reach out to me, and I can get you in touch. So, as we always say, we've all built it the old way. Now let's go build it better.